Welcome to Homework Lib.
Hi, so over here we're going to have a sample of an ancient wooden object that is going to have a ratio of carbon-14 with respect to carbon-12 equal to 3.3 times 10 to the minus 13. And we are going to compare it to a current biological sample that is going to be 1.2 times 10 to the minus 12. We're also told the half-life time for this process that is 5,730 years. And we need to remember that this is going to be a first-order process. So that means that in general, we can look at the concentrations or ratios or mass as an initial value times the exponential of minus k times t. So additionally to that, we know that the half-life time for a first order process is going to be equal to the logarithm of 2 divided by k. So what we're going to do is find what is going to be the age of the object employing these two equations. So first of all, what we can do is calculate the value for k. The value for k is going to be equal to the logarithm of 2 divided by the half-life time. In this case, the half-life time was 5,730 years. So the answer that we're going to get is 1.2097 times 10 to the minus 4. And the units are going to be years to the minus 1. Okay. Now, the values that we're given here are going to be related to the concentration at the time, at the age of the object, and this one is going to be our initial concentration. We're going to assume that a biological sample that was taken at the moment in which the wood was created or it fell to the floor is going to be essentially the same ratio as a current biological sample. So replacing these two values, what we get is that in order to know the time, we need to solve for t on this equation. So solving for t, we're going to get that Ct divided by C0 is equal to the exponential of minus k times t. We take the logarithms on both sides, so this becomes logarithm of Ct over C0 is equal to minus kt. And finally, with this, we know that the time is going to be equal to the logarithm of Ct over C0 divided by minus k. We can take the minus in front of the fraction just to make it look a little bit more appealing. And we're just going to replace the values that we just found. So this is going to be the logarithm. The Ct is going to be 3.3 times 10 to the minus 13. The initial value is going to be 1.2 times 10 to the minus 12. And the value for k is the one that we just found. Notice that the value for time is going to have units of years. And the answer is going to be 10,672 years, rounded up to 5 significant figures. And this would be our final answer for this problem. With that, it would be all. Thank you very much and have a good one.